Hello everyone. Today our discussion will be on application of determinant and matrices. Basically today we are going to discuss about a system of linear equations, how to solve system of linear equations with the help of matrix method and related some other questions. So before we start the system of linear equations, so let us try to revisit the two important terms, that is consistent system and inconsistent systems. This regarding consistent system and inconsistent system, when did you learn? You learn about this two concept from class 10 onwards. Say consistent system. So what is consistent system? A system of equations is said to be consistent if its solutions exist. The solution may be one or many, but if the solution exists, then you say the system is always consistent. And what is inconsistent system? A system of equations is said to be inconsistent if its solution does not exist. That means if we are not able to get a solution, if the solution does not exist, then the system is said to be inconsistent. Let's move to the system of linear equations. So system of linear equations, just we can write in this way: a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. Now what I'm going to do is, we are trying to write this system of equations in matrix form. So to write in the matrix form, we'll first write some matrices. First, we'll write coefficient matrix. Let A stand for, it's a symbol. This will represent a coefficient matrix. What are the coefficient? A1, B1, C1, A2, B2, C2, A3, B3, C3. So with the help of A, we are going to write the coefficient matrix A1, B1, C1, A2, B2, C2, right? Okay. Then A3, B3, C3. This is coefficient matrix. What are the variables are being used here? The variables are x, y, z. So we'll be denoting this by capital X, that is x denote a variable matrix, that is a column matrix x, y, z. And is a constant d1, d2, d3. So that will be denoting with the help of a letter B, that is d1, d2, d3. Right? Okay. This system of equations, if we mark this as 1, now with the help of A, X and B, how to write this? So 1 now can be written in the form of A stands for, this is a 3 by 3 matrix, X equal to B. Okay, this can be represented with the help of this form, that is Ax equal to B. Now we are going to discuss how to solve these equations. So matrix equation, how to solve, that is how to get the value of x. The value of x, to get the value of x, we need to check whether A is singular or not. That means to remove A from this particular place, Ax equal to B, then A inverse, whether it is exists or not, we need to check that. Okay. So there are two cases. The case 1, if A is a non-singular matrix, then its inverse exists. Non-singular matrix means determinant A not equal to 0. Okay. So we'll first discuss about this case, that if A is a non-singular matrix. If A is non-singular matrix, then its inverse exists. So what we can do is, we can multiply these equations with the help of A inverse. So we'll multiply this A inverse, Ax, and we'll multiply right hand side also by A inverse. Okay. Since we know, since we are using the condition is A is a non-singular matrix and therefore determinant not equal to 0, and since it is a non-singular matrix, therefore its inverse exists. And since inverse exists, so it is possible for us to multiply these equations with help of A inverse. These are the steps. So we are going to use the associativity, that is A inverse A X. Then this will remain as it is. Now, what is A inverse A? A inverse A, this is A inverse and this is A. So A inverse is the inverse of A. So if you multiply a matrix with another matrix, and if A is the inverse of B, then, or B is the inverse of A, then AB always equal to I or equal to BA. We know this from the definition of invertible matrices. So since one is the inverse of, that A inverse is the inverse of A, therefore A inverse A equal to identity matrix X, I into X, that A inverse B. So now, if you multiply I and X, so if you multiply a matrix by an identity matrix, so you get the matrix itself, that is X, A inverse B. So this is the value of X, that is X is equal to A inverse into B. So we can obviously solve in case A is a non-singular matrix. And what will be the nature of the roots? What will be the nature of the value of X, Y, Z? Since A inverse. Now let us see like uniqueness of inverse of a matrix. We know that the inverse of a matrix is always unique, and so with the help of A inverse, if you multiply B, you are going to get the unique solutions for X. So this is the first case, that if A is a non-singular matrix, then you get from that matrix equation, that is X is equal to B. So it is possible for us to get the value of X is equal to A inverse B. Now we know how to solve this. So X, obviously that X can be written as X, Y, Z, and we know the value of A inverse. We have done this. What is the value of A inverse? How to find with the help of a simple formula. A inverse is 1 by determinant A and adjoints of A. So in place of A inverse, we'll be writing 1 by determinant A into adjoints of A. Okay, that should be multiplied by, okay, this will be multiplied by B. So in case if we multiply these two matrices, you are going to get a column matrix here in the right hand side, and if you compare both matrices, you are going to get the value of X, Y, Z. Let us move ahead. Let us see the second case. Okay, case 2. If A is a singular matrix, the previous case what we have discussed is non-singular matrix. In case F is a singular matrix, then determinant A is equal to 0. This is the, remember this. This is the definition of singular matrix. If A is a singular matrix, then determinant A is equal to 0. Now what happens if determinant A is equal to 0? So we'll get some very interesting steps. What are those? Okay, if determinant A equal to 0, then we need to calculate adjoints of A into B. We need to calculate these terms. What we have to calculate? Remember this, we need to calculate adjoints of A into B. We need to calculate this. This one we need to calculate. In case adjoints of A into B, okay, you get non-equal to 0 matrix. That you are multiplying this, but you are not getting a 0 matrix. This is 0 means a 0 matrix. What is a 0 matrix? A matrix is said to be a 0 matrix or a null matrix if all the entries are 0. Okay, it's not equal to 0 matrix. Then the solution of the system of equations will not exist. Then the solution does not exist, and the system of equations is called inconsistent. The system of equation will be inconsistent system. Okay, this is for case 1. In case adjoints of A into B is not equal to 0. Okay, now come to the next point. What is that? In case if you get adjoints of A into B equal to 0, that means this 0, you should understand this is a 0 matrix. Okay, this is a 0 matrix. So that's second case. If adjoints of A, B equal to 0, that means 0 matrix, then the system may be either consistent. Here also there may be two cases. The system may be either consistent or inconsistent according to the system have either infinitely many solutions or no solutions. So here, after getting adjoints of A, B equal to 0 matrix, the system may be consistent or inconsistent. If it is consistent, what is the meaning of consistent? Consistent means the system will have solutions. If this is under these conditions, the system may be either consistent, and if it is consistent, the system will definitely have infinitely many solutions. And or other case that it may be inconsistent if the system have no solutions. Okay, so we will be getting two cases under these conditions. What is that? Adjoints of A, B equal to 0 matrix. So based on this one for applications, we are taking one simple questions. Okay, what is the questions? Examine the consistency of the system of equations. We need to examine whether this system will be consistent or not. For that, first we will be focusing on the coefficient matrix. This will be only 8. Okay, we'll focus only the coefficient matrix. Let A, what is the coefficient matrix here? The coefficient matrix is 1, 3, 1, 3, then 2, 6. Right? This is the coefficient matrix. So since this is a coefficient matrix, what is the next steps? We need to check whether it is a singular matrix or non-singular matrix. So we'll just calculate determinant of A. If we calculate determinant of A, then 6 to 1 is 6 minus 3 to the 6 equal to 0. That means determinant A is equal to 0. So what is the case? That determinant A equal to 0. So we are getting this case, second case, determinant A equal to 0. Okay, that is a singular matrix. In case it is a singular matrix, then we may get two cases. What is the next steps? We need to check adjoints of A into B. So let us check what is adjoints of A into B in this case. So for that we need to calculate adjoints of A. So we'll calculate adjoints of A now. So here, adjoints of A. Okay, what is adjoints of A? Adjoints of this matrix. So to calculate adjoints is very simple. For 2 by 2 matrix, what you need to do is, we'll interchange this diagonal element. 6 and 1 will interchange, that will be 6. These are all points we have discussed in our previous videos. And the non-diagonal elements will remain as it is, but their sign will be changed. So what are the numbers we have written? 1, 3 and 2, 6. This is said to be a coefficient matrix, and 3 and 2 are in non-diagonal positions. So we'll have to write as it is, 3 and 2. But what? That this sign will be definitely minus. That is 6 minus 3 minus 2, 1. So this is adjoints of A. Now what is left out? It is left out to calculate adjoints of A into B. So we'll calculate adjoints of A now. Adjoints of A, B. So what is adjoints of A? 6 minus 3 and minus 2, 1. And what is B? B is the constant matrix, that is 5 and 8. This is only 8. 5 and 8. So multiply now. 6 5 the 30. 6 5 the 30. And 8 minus 3. That is minus 24. That is minus 24. Then again we will multiply. That is minus 2 into 5. That is minus 10. Then is plus 8. Okay, that is 30 minus 24. 30 minus 24 is 6 minus 10 plus 8 is minus 2. That means this is equal to 30 minus 24 is 6 and minus 10 plus 8 is minus 2. So obviously this is not equal to a 0 matrix. This is not equal to the 0 matrix. Have you seen this case? Adjoints of A into B not equal to 0. Here we also got the same thing. So in case adjoints of A into B is not equal to 0, then the system, the given system, this given system obviously will be inconsistent system. So you can revisit this theory that if adjoints of A into B is not equal to 0, then the solution does not exist, then the system is said to be inconsistent. So our answer will be the given equations the given system of equations is inconsistent. Okay, let us try some other questions. This question is given to solve. Okay, it is not asking any other steps. It's not mentioning whether the system will be consistent or inconsistent. The question is that you need to solve these equations, and to solve we'll be using the matrix method. Let's start with step 1. What is step 1? First we'll write a coefficient matrix. Okay, let A. What is the coefficient matrix here? 4 minus 3, 3 minus 5. This is our coefficient matrix. Right? So what we need to check, first step is we need to check whether it is singular or non-singular. That means we need to calculate determinant A. If we calculate determinant A, that is 4 minus 3, 3 and minus 5. Okay, we'll just calculate. So 4 into minus 5 is minus 20. Then 3 into 3 is minus 9. There will be one extra minus, so it will be plus 9 equal to minus 11. So this determinant A is minus 11, and this is not equal to 0. This is not equal to 0. That means the given system of equations, okay, from the given system of equations, that the coefficient, from the coefficient matrix we got determinant A is not equal to 0. That means the given matrix is a non-singular matrix. Okay. So we'll write the system of equation in matrix form now. From the given system, of equations, we can write Ax equal to B. So A is this, and what is x? Here x will be xy. This is the point I have discussed in the previous questions. X will be xy because here only two variables are used, and B will be the constant, that is 3 and 7, right? Ax is equal to B. So since A is the matrix is a non-singular matrix, therefore A inverse exists. So from here you can directly write x is equal to A inverse B. X is equal to A inverse B. So now we are going to calculate the value of x. Okay. So to calculate the value of x, we need to calculate A inverse. So what is A inverse? So to calculate A inverse, we need to calculate adjoints of A. Okay. First we will calculate what is the adjoints of A. So adjoints of A for this matrix, okay, you can write this adjoints of A. Adjoints of A. What will be adjoints of A? Adjoints of A will interchange these places. Minus 5, 4. Minus 5, 4, and will interchange the diagonal elements, and non-diagonal elements will remain as it is, but their sign will change. This minus 3 will be plus 3, and this 3 will be minus 3. This is adjoints of A. Okay. Now after calculation of adjoints of A, you can calculate A inverse. What will be A inverse now? So inverse you can calculate A inverse. A inverse will be 1 by determinant A. What is determinant A? It's minus 11. And adjoints of A. So got adjoints of A is minus 5, 3, and minus 3, 4. Minus 3 and 4. You got this A inverse. Now what is left out? Only left out that we need to multiply A inverse into B. So we'll multiply this one with the help of B. Okay. So we'll multiply this last steps, that is A inverse B. So here x is equal A inverse B. So I'll just write A inverse value. A inverse value is 1 by minus 11, and this is minus 5, 3, minus 5, 3, and minus 3, 4. So this x is equal to A inverse into B. B value is what? B value is 3, 7. Okay. So we'll just multiply, we'll continue this one here is equal to minus 1 by 11. Then we'll multiply minus 5 into 3. Minus 5 into 3 is what? Minus 15. Then you need to multiply 3 into 7. 3 into 7 is 21. Right? It's 21. Then next, first row and first column. Then secondly, to get the second element, the second row, utilize the second row, minus 3 into 3, it's minus 9. Then you need to multiply 4 into 7. 4 into 7 is 28, right? Okay, so what's the next steps? It's minus 1 by 11, minus 15 plus 21 is 6, and minus 9 plus 28 is equal to how much? It's 19. Right? Now finally you need to divide 6 and 19 by minus 11. So finally your answer is minus 6 by 11 and minus 19 by 11. Okay. What is there in the left hand side? Left hand side is x is there. X stands for xy. X stands for xy. So what is the value of x? Therefore value of x equal to minus 6 by 11 and the value of y is minus 19 by 11. Okay, these are the unit solution of the given system of linear equations. What are the steps? I'll just repeat once. This is a system of linear equation is given. We need to solve. So first we are writing the coefficient matrix. Step 1. After that we need to check determinant A. And since determinant is not equal to 0, so we definitely convert the system of equations to matrix form. And this matrix form, you can write x is equal to A inverse B. The theory I have explained before some time, that if Ax is equal to B, A inverse exists. And with the help of the A inverse, application of A inverse, that Ax is equal to B can be converted to the form of x is equal to A inverse B. While solving this, those are the steps you don't need to show. That Ax is equal to B obviously implies x is equal to A inverse B. But remember one thing, before you write the steps, these are the steps to be shown. Okay. Next, so x is equal to A inverse B. So what is needed here? We need to calculate A inverse B. So before you calculate A inverse, you need to calculate adjoints of A. You are calculating adjoints of A. After calculation of adjoints of A, go for A inverse. A inverse. What is the formula for A inverse? The formula for A inverse is 1 by determinant A into adjoints of A. We have learned this formula. A inverse is 1 by determinant A adjoints of A. This is the formula for A inverse. So A inverse 1 by determinant A adjoints of A. Now, since you got the A inverse, you please don't multiply this. These are the elements you don't need. You will multiply. That means don't insert 1 by minus 11 to the matrix. Why? Because unnecessarily the calculation will be difficult. Okay. So leave it as it is. Now finally the steps here. X is equal to A inverse B. So write x. X stands for xy. And here you are writing A inverse multiplied by B. Then multiply this. Leaving 1 by minus 11 as it is. You multiply this. Okay. After multiplication you are getting one column matrix. This, and then finally after calculation solve all the steps, then finally you multiply the elements by minus 1 by 11. You are multiplying this, then it's a column matrix, and in the left hand side x also a column matrix. Then when matrices will be equal, then this A11 element will be equal to this element, and this element A21 element will be equal to this. That means x will be equal to this and y will be this. So this is the solution for this system of linear equations. Then we will be taking another questions consisting of 3 equations. Okay, and the matrix will be of 3 by 3 order, and this question will have some steps. First we'll start like the previous questions. Okay. First we'll start with the coefficient matrix. So we'll start the solutions. Here the coefficient matrix. First we'll write the coefficient matrix. So A, what is the coefficient matrix? Okay, just 2, 3 and 3. First row, what is the second row? 1, minus 2, 1. Then 3, minus 1 and minus 2. Remember this, the entry should be always correct. 2, 3, 3, right? 1, minus 2, 1. Then 3, minus 1, minus 2. And if you are watching this video, along with me, please keep solving these questions. Okay? A equal to this. Then what's the next steps? Like we have done The next step is this. Very important. What is the next step? To calculate determinant A. Okay. To calculate determinant A, we will convert this matrix to determinant 2, 3, 3 and 1, minus 2, 1. That is 3, minus 1, minus 2. Okay. Then we evaluate this, the determinant. So if you expand along the first row, this is 2. Then minus 2, minus 2. So it will be plus 4. Then you need to multiply 1 into minus 1. 1 into minus 1 is minus 1. Then there will be 1 extra minus sign. So it will be plus 1. Right? Then you need to expand along 3. So since 3 position is 1, 2. So it will be minus 3. Then since you are expanding along 3. So you need to multiply 1 and minus 2. It's minus 2. Then you need to, there will be 1 more minus sign. You need to multiply 3 into 1. So it will be 3. And finally, you need to expand along 3. So it will be plus. You can also check like that. It's expanding along 2. It's plus, minus, plus. It will go like that. If you expand along 3, so you need to multiply 1 into minus 1. It's minus 1. And then 3 into 2, 3 into minus 2, it's minus 6. There will be 1 more minus sign. So it will be plus 6. Right? So along 3, 1 into minus 1, it's minus 1. Then 3 into, so when you multiply 3 into minus 1, there will be an extra minus sign. There is 1 more minus sign is already there. So it will be obviously plus. 3 into 2 is 6. Let us calculate what is our value. Okay? The value is 4 plus 1, 5. 5 into 2. How much? 10. Here minus 3, minus 2. Minus 3, minus 2 is what? Minus 5, minus 5, minus minus plus. And 5 is a 15. Right? And here minus 1 plus 6. Minus 1 plus 6 is 5. 5 into 3. It's 15. Okay. That is 15. 15. 30 plus 10. It's 14. That is not equal to 0. Okay. So the given system we can write in the form of. Okay. This given system we can write in the form of x equal to A inverse B. We can write in the form of this. We have discussed the previous question also. X is equal to A inverse B. Now, what we did, we know like this system will have the unique solutions. Okay, since the system will have unique solutions, we need to calculate A inverse and B. So for A inverse, already 1 by determinant A you have calculated. Most important that you need to calculate adjoints of A now. So we'll calculate adjoints of A. To calculate adjoints of A, how many elements are there? 1, 2, 3, 9 elements are there. So that means you need to calculate the cofactor of all 9 elements. Now cofactor of all 9 elements, there is no shortcut like to calculate the adjoints of A, the 3 by 3 matrix. So you need to calculate the cofactor of each and every element. Okay. So we'll just calculate first the cofactor of all the 9 elements. So cofactors always denoted by capital A. So we'll just calculate A11 and A12, A13, then A21, A22, A23. We'll calculate the cofactors. Then A31, A32, A33. So this is one method where we are separately finding the cofactor of each and every element. Okay. So this is one method I say that. Okay. Here initially we start with this method so that we can just, there is a chance of making less error by this method, or in case you find that here it will take more time, so this adjoints of A directly within the matrix itself you can calculate. Okay, I'll just discuss about that point. First we'll calculate all the 9. Here also it will not take much time. We'll calculate all the 9 cofactors. A11 means you need to calculate the cofactor of 2. If you need to calculate the cofactor of 2, what will be the cofactor of 2? You need to see the moment. Already I explained how to find the cofactors. So you need to ignore this row, you need to ignore this column. So you need to multiply it. Minus 2 into minus 2 is plus 4 and minus 1 into 1. There will be 1 more minus sign. It will be plus 1. So 2 plus 1. It will be 5. This element will be 5. Next, 1, 2. You want to calculate the cofactor for 1, 2. That means this element. Remember this. To calculate the cofactors, you need to multiply by minus 1 to the power. This always, when you calculate the cofactors, say A11 you are calculating the cofactors, then already I discussed about that. You need to multiply by minus 1 to the power 1 plus 1, then you need to calculate the minus. But here what I will be doing is, alternatively you will take plus minus sign. So it's 5 second element for 3. We will calculate the cofactor for 3. That means, have you seen the suffix 1, 2? We need to calculate the cofactor for 3. So first 1 into minus 2. 1 into minus 2 is minus 2. Then there will be 1 minus sign, that is 3 into 1, that is minus 3. It is minus 2 and minus 3. Minus 2 minus 6, minus 5. Right? Minus 5. But what is the position of 3? Position of 3 is 1 to position, so we need to multiply by 1 minus sign. So it will be plus 5. Okay, 5. Now 1, 3. That is cofactor of 1, 3. 1, 3. This element. You need to multiply 1 into minus 1. That is minus 1. Then you need to multiply 3 and minus 2. 3 and minus 2 will be what? Minus 6. But there will be one more minus sign here. So it will be plus 6. And here 1 into minus 1. Okay. And 1 into minus 1 is minus 1. And 3 into minus 2 is minus 6. Multiplied by another minus sign. So it will be plus 6 and minus 1. Plus 6 and minus 1 is 5. But again, this element, what is the position of this element? The position of element is 1, 3. That means 3 plus 1 is even number. So since 3 plus 1 is even number, this 5 should not be multiplied by minus sign. It will remain as 5. Now 2, 1. This is 2, 1. This element. 2, 1. So to calculate the cofactor of 2, 1, you need to multiply 3 into minus 2. 3 into minus 2 is minus 6. And I'll just write here. And what is the position of this element? The position of this element is what? 2, 1 position. 2, 1 means 2 plus 1 is odd number. So there will be 1 minus sign. Right? Okay. This minus sign. Then you will multiply this. Okay. 3 into minus 2. 3 into minus 2 is minus 6. Minus 6. Then you need to multiply this 3 into minus 1. So to multiply 3 into minus 1, there will be 1 extra minus sign. So it will be 3 into minus 1 is minus 3. Multiplied by 1 more minus sign, it will be plus 3. So it will be plus 3. Okay, so I'll just repeat this. And why I am putting the minus sign? This minus sign stands for, that is, what is the sum of these two numbers? 2 plus 1 is odd number. So this number will be multiplied by, as I explained here, minus 1 to the power. Here this term will be multiplied by minus 1 to the power 1 plus 2. That is minus 1 to the power 3. Minus 1 to the power 3 obviously will be minus. So therefore it's to be multiplied by minus. This also I have done. This one I have done already. Okay. So minus, and then this 2, 1 position element. So 3 into minus 2 is minus 6. Then there will be 1 extra minus sign. 3 into minus 1 is minus 3. And minus another minus sign will be there, plus 3. So finally, what is the element? That is minus 6 plus 3 is minus 3. Minus 3 plus minus 3 multiplied by minus 3. So it will be plus 3. Then 2, 2. So 2, 2. This cofactor of this element. 2 into minus 2. 2 into minus 2 is, okay, minus 4. 2 into minus 2 is minus 4. Then 3 theta. There will be another minus sign. 3 theta 9. Okay, that is minus 9. Minus 9. Now here outside the bracket, like you don't need to multiply by minus sign because 2 plus 2 is an even number. So it should be multiplied by plus. So it will be minus 30. Right? A23. Now cofactor of A23. Cofactor of this element. Cofactor of this element. 2 plus 3 is odd number. So it will be multiplied by 1 minus sign. Okay? Minus this element. So what do you have to multiply? 2 into minus 1. 2 into minus 1 is what? Minus 2. This is minus 2. This is minus 2. 2 into minus 1. It's minus 2. And there will be one more minus sign. 3 is a 9. Okay? Minus 3 is a 9. Minus 9. Okay. Finally, what do you get? Minus 2, minus 2, minus 9. Minus 2, minus 9 is what? Minus 11. And outside there is a minus sign, so multiplied by minus. So is equal to how much? Is equal to 11. Right? So how did you calculate 2, 3? And 2, 3 position is this. Remember this. 2, 3 position is this. So 2 into minus 1 is minus 2. And minus, there will be minus by multiplying this 3, 3. So it will be 3, 3, 9. So minus 9. And this is minus 2. Minus 2, minus 9 is minus 11. But this element will be multiplied by what? Minus 1 to the power minus 1 to the power 2 plus 3, that is 5. So it will be multiplied by minus sign. So since there is a minus sign and minus 2 minus 9 is minus 11 multiplied by minus, so it will be plus 11. Finally, the last row cofactors. Last row cofactor is this A31. This A31. So A31, 3 plus 1 is even number, so we are not going to multiply by minus sign. So it will be 3 into 1 is 3, then minus, but there is one more minus sign, it will be plus, okay, plus, then 3 to the 6, this is 6, 6 plus 3 is 9, right? Then A32 is this, A32. Now A32, remember this, A32, this element, so you have to multiply 2 into 1, 2 into 1 is how much? 2, then minus 3, 2 minus 3 is minus 1, 2 and 3 into 1, it's minus 1, but what is the position of 3, 2? The position of this element, 3, 2 positions, then 3 plus 2 is an odd number. So therefore, finally, this 2 minus 3, you got minus 1 and minus 1 multiplied by minus sign, so it will be plus 1. Then finally, A33, and 3 plus 3 is an even number, so you don't need to multiply by minus 3. So it will be 2 into minus 2. 2 into minus 2 is what? Minus 4, and 3 into 1 is minus 3. You multiply this, 2 into minus 2, it's minus 4, and you need to multiply 3 into 1. 3 into 1 means it's minus 3. So minus 4 minus 3, it's minus 7. So you got the cofactor of all the 9 elements. After finding the cofactor, how to write the adjoints? You need to interchange the rows and columns to get the adjoints of the matrix. Okay, so we are going to write the adjoints matrix. So what will be the adjoints? Therefore, adjoints of A. I am writing the adjoints of A. What will be adjoints of A? What is the first row cofactors? First row cofactors will write at the first column. So it will be 5. This will be 5, and this is also 5, and this is also 5, because this is the first row cofactor. 1, 2, 3. So this first row cofactor you need to write column wise. So that means we are together, we are transposing, writing the cofactor and we are taking transpose together. Then the second row is 3 minus 13. See the second row, 2, 1, 2, 2, 2, 3. That is 3 minus 13, and this is equal to 11, right? Then coming to the third row, okay, third row will make us third column, that is 9, and this is equal to what? A32 is 1, and A33 is minus 7. A33, this position is minus 7. So you got the adjoints of A. So what is you got? That means A inverse, you got the 1 by determinant A, and you got the adjoint. So finally one step is left out, then you need to multiply adjoints of A into B. So only that step is left out. We are going to multiply adjoints of A into B. So how to multiply adjoints of A into B? So we multiply adjoints of A into B. So if you multiply adjoints of A into B, okay, this is adjoints of A, and we'll multiply, okay, adjoints of A into B. That means x equal to A inverse B. X is equal to A inverse B. So A inverse means 1 by determinant A, adjoints of A, B. Okay, adjoints of A, B. So what is 1 by determinant A? Determinant A means 1 by 4, 0. So adjoints of A you have already done. That is 5, 3, 9. Right? That is 5 minus 13, 1. Then 5, 11 minus 7. Okay? This is the value of the A inverse. 1 by determinant A, adjoints of A, and into B. So 1 by determinant A, this is determinant A, 1 by 40, and this is adjoints of A, and to B. What is B? B is 5 minus 4, 3. 5 minus 4, 3. Yes? So finally we are going to get what? One column matrix here. So we'll just multiply. 5 5s are 25. Okay? 5 5s are 25. Right? Then 3 into minus 4. 3 into minus 4 is minus 12. Minus 12. And this is 9. 9 into 3. That is 27. Okay, 5, 3, 9. This is 5. That next 5, 3, 9. 5, 3, 9. This is 9. Okay, I'll just multiply 5, 5 is 25. 3 into minus 4 is minus 12, and 9 into 3 is 27. Right? Okay. Next is we'll multiply this one. Second row with this column. 5 into 5, 25. Okay. Then minus 13 into minus 4 is 52. Then we need to multiply 3 plus 1, that is 3. Then next, what do you need to multiply? 5 into 5, 25. Then 11 into minus 4 is minus, okay, 44. Then finally you need to multiply minus 7 into 3, that is minus 21. Let us calculate this column. The last column, let us calculate. The left hand side is here x, that is x, y, z. And right hand side is 1 by 40. And let us see the calculations. 25 minus 12. 25 minus 12 is 13. 13 plus 27. 13 plus 27 is 40. Okay? 13 plus 27 is 40. Now 25 plus 52. What is 25 plus 52? 25 plus 52 is 77. Okay? 77 plus 3. 77 plus 3 is 80. Then 25 minus 44 minus 21. So 25 minus 44 minus 21. 25 minus 21 is 4. Then plus 4 minus 44 is minus 40. Okay. Now finally we'll multiply each and every element by 1 by 40. If you multiply that first element, okay, what will be the first element? That is 40 by 40, it's 1. Then 80 by 40, 2. Then minus 40 by 40 is equal to minus 1. So if you compare now, so here in the left hand side also column matrix, the right hand side also column matrix. So finally if you compare, x will be equal to 1 and y will be equal to 2 and z will be equal to minus 1. Okay, so this is your solution of the system of linear equations. Okay, so here what method we are applying? We are calculating all the 9 cofactors together, A11, A12, A13. This is also one very simple as well as a method that is suggested by NCT books. First, that calculations of all 9 cofactors separately, then you need to calculate. Okay, and slowly when you'll be used to solving like these questions, instead of calculating all the 9 cofactors separately, this adjoints of A, you can calculate first. You can write adjoints of A. I can just tell you the one more steps in this regard, that how to solve can be solved in an other way also. Here, if this system of equations, that if I just talk about the alternate method, what could be a simple method, equally simple. Okay, I am suggesting the first method because from my experience, I understood that most of the students like this method. Okay, because they want to take a chance in exams, like they want to get 6 out of 6 from these questions. Okay, but like there will be some student who is fond of first calculations, or they make less calculation errors. Okay, they can just go by this method as well. What is the method here? So here I will not repeat everything, only adjoints of A, I will focus only adjoints of A. So what you have to do, here we know that the system of equations, we will be writing the given system of equations is this, and this can be written as x A inverse B. First we will check, obviously before that, we will first check determinant A. Okay, here determinant A equal to 40, not equal to 0. Then you will go to this step, x equal to A inverse B. Then you know like the most important here, where time consuming is to calculate A inverse. Okay, and to calculate A inverse, you know that A inverse equal to 1 by determinant A adjoints of A, right? 1 by determinant A adjoints of A. Now we need to calculate. I am just discussing this point twice only to explain you adjoints of A. Now adjoints of A also can be calculated like this. Adjoints of A, you write directly this and write the transpose here. Now what you need to do, as it is 9 elements, where is your matrix? This is the matrix. That is 2, 3, 3, that is 1, minus 2, 1, and 3, minus 1, minus 2, right? So all 9 elements as it is. You don't need to think for interchanging rows and columns because you have written already transpose. As it is, you keep writing all the 9 perfectors. Calculation you can done roughly also. You can directly write the perfectors and then you take transpose. So you get the adjoints, and the remaining steps will be exactly same as the other steps of this particular sum. Okay, let's move to the last question of today's video. Okay, what is the question? If a equal to 2 by 2, 3, 1, minus 1, 2, show that a square minus 5a plus 7i equal to 0, and hence find a inverse. So there are two parts of answer here. First part, you need to show that a square minus 5a plus 7i equal to 0, and remember this word is very important. What is that? Hence find a inverse. That means using this equation only you need to find a inverse. Okay, you please don't find a inverse directly from this matrix using the formula, that is 1 by determinant A adjoint of A. Please don't go with that method. You need to use this particular equations. So first we'll divide this answers into two parts. That is our first part. Okay, this is first part of the answers, and we will solve the second part. Second part of the answers. So the first part. What is first part? We need to calculate a square minus 5a plus 7i. This is identity matrix. Remember this. We'll calculate a square first. A square. How to calculate a square? 3, 1, minus 1, 2. That is 3, 1, minus 1, 2. We'll calculate this a square first. Okay? First, this row and this column. 3 3s are 9. Then 1 into minus 1. That is minus 1. Right? First row, first column. 3 3s are 9, 1 into minus 1. Then you're going to get the second element. 3, okay, first row, second column. 3 into 1 is 3. Then plus 2 into 1, that is 2, right? Second element. Now go for this element. The second row, 1 into minus 3, that is minus 3, right? This is minus 1 into minus 1 into, see, second row, first column, minus 1 into 3, that is minus 3. Then 2 into minus 1, that is minus 2. Then go for the last element. Second, same row with the second column, minus 1 into 1, that is minus 1, then plus 2 into 2, it's 4. So what is this matrix? This matrix is 8, 5, minus 5, and 3. We got this matrix. Now we need to substitute here. So we'll write these equations. A square is equal to 8, 5, minus 5, 3, and then minus 5a. What is a? A value is this. A, 5, minus 5, 3. Right? Then plus 7 into I. What is I? I is an identity matrix. Here the matrix is 2 by 2. So identity matrix should also be ordered 2 by 2. Right? Now we need to add this. Let us directly add this. What will be this? If we add. Now check the first element. Then A1, one position element. Here it's 8. Okay? This is 8. And this first element is 8. And here this is minus 5 into 8. Remember this. Here actually this element. This is 8, 5, minus 5, 3. But this element has to be 8. This is A. It's not to be a square. I have written a square. It's not to be a square. This is A. This not is this element. First, this element to be only A. A means what? 3, 1, minus 1, 2. This is 3. Okay. This is 3. And this element has to be 1. This is element has to be 1. And this element. Okay. So I have written a square value here also. It should be only A. So I'll just correct this. 3, 1 and minus 1. This is minus 1 and this will be 2. So what are the elements I have written? This is A element. Remember this. This is A. This is 3, 1. 3, 1, minus 1, 2. Right. Okay. Now this is 8. And this is 8. This is plus 8. This is plus 7. Plus 7 into 1. So 8 plus 7 is 15. And here minus 5 into 3. Minus 15. So here if we add, because we know how to add matrices. Okay, same position element to be added or subtracted. Here 2 plus numbers are there. 8 plus 7 is 15. and here minus 5 into 3, it's minus 15. So the first element obviously will be what? It will be 0. Now go for the second element. Second element, 1 position element. Here is 5 and here is, this is 1. Minus 5 into 1, that is minus 5. 5 minus 5, here is already 0. We need to calculate only 5 and this is minus 5 into 1, that is minus 5. 5 minus 5, obviously it will be 0. Similarly, you can show that this element, that is 2 1 position element, this is minus 5 and this is minus 5 minus 1, it will be plus 5. Minus 5 and plus 5 will be 0 and you don't need to calculate this because this position element 0 into 7 is already 0. You need to only compare it. This is minus 5 and minus 5 into minus 1, that is plus 5. So minus 5 plus 5 will be 0. Then finally, what is this? This is 3 and this is, remember this is 2 by 2 position element. This is 3 and minus 5 into 2. It's minus 10 and this is 7 into 1. Okay, 7 plus 3 is 10 and minus 5 into 2. It's minus 10. So it will be 0. Okay, so this is, all the entries are 0. Therefore, this is what? This 0 is stand for, remember this, 0 matrix. Okay, therefore all the entries are 0. So therefore this is a 0 matrix. So first part is proof. Okay, that is first what we have done, we are calculating a square, then a square minus 5, this is a, 5 into a plus 7, and let's calculate all the entries will be 0. So hence the first part is proved. The second part. Okay, so since we can write since because we have just proved a squared minus 5a plus 7i equal to, remember this, it's a 0 matrix, we have just shown. Okay, what is the next step? So we'll multiply by A inverse. A inverse, okay, that is each term will multiply by A inverse. That is left side we will multiply this. A inverse into A squared minus 5 A inverse A, because the scalar will come out plus 7 and you have to multiply I by A inverse. A inverse I. And right hand side, if you multiply by A inverse, it will be 0 only, 0 matrix only. Now we will be using the associativity. How to use associativity? A inverse A, 1 will be there. Because A square stands for A into A. So A inverse A into A, that is, this is minus 5. A inverse A is I. Because if you multiply a matrix by inverse matrix, it will be an identity matrix. Then we will transpose this term to that side. What is A inverse? You are multiplying identity matrix by A inverse. So if you multiply A inverse is the matrix, so if you multiply a matrix by identity matrix, you will get the matrix itself. So if you transpose, it will be minus 7 A inverse, because A inverse into I is A inverse. So we are transposing that side. Okay. Next, what is the next steps? This is A inverse A equal to identity matrix. And then identity matrix, if you multiply by A, so you will get only A. Okay, minus 5I, and this is equal to minus 7A inverse. So what is our question? Our question is to calculate A inverse. So we will get A inverse, we will transpose minus 7 this side and we will substitute the value of A. What is the value of A? Value of A is 3, 1, minus 1, 2. Minus 1, 2, right? This is A. Then, what is identity matrix? It's a 2 by 2 identity matrix. 1 0 0 1. If you multiply 4 element by 5, it will 5 0 0 5 equal to minus 7 A inverse. So only just one simple step is left out. We are calculating this. Finally, what will be the final steps? A inverse will be will transpose this minus 7 to right to this side. So it will be minus 7. Now we need to calculate this. We'll calculate this. This is 3. The first element, see? The first element is 3. Here the first element, 1 element is 3. Here 1 element is minus 5. So 3 minus 5. 3 minus 5 is what? Minus 2. Right? You got this element as minus 2. 3 minus 5 minus 2. Then here what is this element? Here is 1. And what is this element? 0. Okay? This is minus 0. So 1 minus 0. It will be obviously 1. This is 1. Now what is 2 1 element? 2 1 element is here minus 1. Okay, here it's minus 1. This is A minus 5, right? This is minus 1. And what is the element? 0. So 1 minus 1 minus 0 is minus 1. And what is this element? This is 2. Okay, this is 2. and minus 5. So this is this 2 and minus 5. You need to subtract. 2 minus 5 will be minus 3. So finally the A inverse is 1 by minus 7, minus 2, 1, minus 1, minus 3. 3 minus 5 is minus 2, 1 minus 0 is 1. This is minus 1 and this is 0 element, minus 1. This is 2 and minus 5. 2 minus 5 is minus 3. Okay. So finally you got the inverse with the help of these equations. So like these equations are very common and simple and interesting. Okay. Today we have included many different concepts in this video, and the next video will be based on the miscellaneous exercise of determinant. And thank you so much for watching my video, and I'll definitely come with a next video with the help of some very important, interesting questions, and where I'll try to include some questions which are marked as HOTS by CBSE, okay, so that it will definitely help you for your board exam as well as for your entrance. Till then, thank you so much.